Alright, the behavior of the graphs of a power function where I have negative power. So, and I'm specifically going to look at negative integer power. So n is negative and an integer. An example would be something like f of x equals 2x to the negative 2, or g of x equals 5x to the negative 3, right? So n is negative, right? Negative values. And so remember what the negative really means, reciprocal. So this would have been 2 divided by x squared. This one would have been 5 divided by x cubed. And so these are, whenever it's the negative case, they can always be rewritten as a over x to the n, whatever that n is, the opposite. So it's negative because I moved it down, and so that would cancel out negative 2. The negative of negative 2 comes out positive 2. And so these are always rational. Simple rational functions, they always have the same behavior. They always have a vertical asymptote at x equals 0, right? I can't plug 0 in, or otherwise I get division by 0. And a horizontal asymptote at y equals 0, because the degree of the numerator is always going to be 0, it's just a number, divided by the degree of the denominator, which is always going to be bigger, right? You're always going to divide by a bigger degree, and so you're always going to approach the x-axis. And so that's always the case for either one of these. Now, if it, again, comes down to even and oddness, so I'm going to look at the first one. If I have an even degree, even negative integer, like that first example, like f of x, which is 2x to the negative 2, which is really 2 divided by x squared. The shape of that graph, if you graph that out on your calculator, the shape of the graph would be what approaches, there's an asymptote there, there's an asymptote there. All right, the shape of this graph, if you graphed it out on your calculator, there's a break at 0, it's asymptotic behavior at 0, and it does approach the x-axis, the y equals 0. And so that's always true no matter what case it is. So again, if you were just generalized case, so if I did another one where suppose I had h of x equals 5x to the negative 4, it would follow the same shape. What would happen is it would approach it a little faster. Right? The graph would be a little skinnier in that case. So if it's an even negative integer, it's always going to have this shape. Well, what shape does it have? It's an odd negative integer. So now we have the odd negative integers cases. So odd negative integer would be more like the g of x example. Would be 5x to the negative 3, which was 5 divided by x cubed. And so if you graphed that out, the shape that comes out in this odd case, well, you still have an asymptote at 0, right? I can't plug 0 in. The degree of the denominator is still bigger than the degree of the numerator, so it's still going to approach 0 on both sides. But the shape of this is different. On this side, it stays positive. So this is the first piece. And so it's positive because when you have an odd degree, it stays positive. When you have an odd degree, though, negative also stays negative, so it's on this side. So this is if I have odd negative integers. So if I had another function, suppose h of x was 3x to the negative 5th, which would be 3 over x to the 5th, it would have that same shape. Now, it would just be a little quicker getting to the axes. It would be a little steeper when it came down, but it would have the same general shape. There would be an asymptote at 0. It would approach the x-axis at the tails. This half would be on the positive side. This half would be on the negative side. All right, that's always going to be the case for the simple power functions when I have an odd negative integer. If you graph this on your calculator, or graph this on your calculator, that's the shape that should come out. So odd negative integers have this shape. Even negative integers have this shape, and asymptotes at the 0, both the axes. And so the last example, so we'll stop the video there. The last one we're going to look at are our root cases. The root cases are a little weirder, all right, because there's more that can happen with the roots, because I can have mixed roots. All right, so we'll look at the fractional cases next.